Welcome to the next video. Today we will produce these struts here that are used in the 5-axis do-it-yourself module. Besides the Fusion walkthrough, I will also guide you in the manufacturing process by showing every essential steps that we need to go through. We will be using mainly two cutters, which is the 4mm single flute end mill and the 90-degree chamfering tool. We will also do some manual work that is needed to finish these parts up, leaving us with this result here. Let's start by going through Fusion first. Setup 1 was what we did last time, preparing the subplate. Today we will work on setup 2, 3 and 4. These setups are used or created to produce these struts here. I will go into the simulation. The first setup is just for cutting the holes where we put our screws in. So it will cut some holes so it matches our threads that we have placed in the subplate in the last episode. When we then continue to setup 3, here we just do a facing operation followed by a pocket operation. Facing operation is just to make sure we have a flat surface, and the pocket operation is basically just making sure that it's not only flat but also very smooth without any ridges created by the milling process. So basically just a very small step over, so we have it extra smooth. Then to the big one. The big one is the setup 4, where we will have a bunch of operations. The screws you can see here are again used on the same positions, just from the other side. Let's jump in the simulation again. We will start with a pocket function, but we have set this boundary, these lines or these sketches that you see here. So we are just cutting away this material here because we don't need to go over the whole raw material. We will work downwards till we have made enough space for the next operations to kick in, which would be the flat operation. The flat operation will take care of making the upper surface very smooth again. Again, it's just a very small step over, running over this material. Once this is done, we want to cut through basically the contour of these parts here. So it will cut deeper and deeper, always going a little bit to the left and a little bit to the right. This ensures that the friction on the tool is reduced, which is very important for deep cuts like we do here. After we have cut down here, we will use a ramp function. The ramp function will take care of the vertical surfaces, making them also very smooth. It will be followed by another ramp function, basically following the same path as the one before, to make sure that the tool deflection will not cause any inaccuracies. Lastly, we have our 90-degree chamfering tool, just cleaning up the edges. And if you're deeper interested in, for example, how I set up the setups, you're free to check it by right-clicking on them and clicking Edit. You can check the depths and information all here. Same goes like last time I explained to you for any kind of operations or tool parameters that are set. You can do the same thing. You can right-click and edit, check all the parameters that are set. Anyways, if you have any doubts or something is left out, feel free to reach out to me. I'm very happy to also discuss points in the comments with you. Let's jump to the machine. We start by mounting the 4mm end mill and make sure that this distance here is 22mm. We move the machine home. After the machine has finished its home sequence, we will go to our 0 point, then we jog downwards, and then we will touch off our tool on this surface here. We go up 100 millimeters and the 20 millimeters backwards, so we are in the center again. For the next videos you can already prepare these raw materials here. Make sure that you remove all the edges so it lays flat on the subplate, and also mark the middle of the raw materials. It makes it easier to place it correctly. Now we start with setup 2 underline A. Also take a note of which holes I'm using for the Snapmaker fixtures, so you don't run into any collisions with them. So as we can see, the setup 2 underline A is already running, cutting the holes, and also the second set, the deeper ones, the small 5.5 millimeter holes, we will not cut all the way through to not damage our subplate, because there is a very simple trick to get these holes out by just using a hammer and a screw and punch it through. I also make sure that I deeper these edges here, and then it will go back onto the machine. I use a set of in total 8 screws here to fix it, and then I go back to my 0 point. I don't need to set a new one, I can use the same one as before. And we will start with setup 3 underline A, which will be first the facing operation, cutting from the right side to the left side, always a climb movement, and it will make sure that we even out this raw material. Don't be worried if in the beginning it looks like this, because it will make another go, and make sure that we have cut deep enough so we have reached every point on the plate itself. And now let's also make sure that it's not only flat but also smooth, with a step over of 0.5 mm and a depth of only 0.1 mm. Once this is done, we are ready to remove the part from the subplate. And as you can see here, the surface is shiny, so we did a good job of achieving a smooth surface for us. Make sure that you deeper all the edges from the holes and also the outer edges, and then we flip the part and we will mount it on the subplate again using this full set of 8 screws. Please take your time in deepering the edges, because any ridges that stand up would cause the part to not stay perfectly flat on the subplate, which would just lead to inaccuracies that we don't want. Now it's time to start setup 4 underline A. We start by doing a pocket function. This pocket function has a machining boundary. So what I wanted to achieve is that the machine stays inside specific areas with the G-code it generates. How I did it? I just created some sketches on the parts themselves, and these sketches are just outer contours around the silhouette of the part I want to produce. As you can see, in this pocket function we are working with a pretty big step over. This is intentional because right now we don't care about surface quality, we care about material removal rate. Once we have cut the majority of this upper surface, we will switch to another operation, a flat operation. This operation runs with a very small step over of 0.5 mm and a very shallow depth of 0.1 mm. In this video section you can clearly see the difference from the ridgy-like surface compared to the new surface that is cut now, which is much more shiny and smooth. Once we have done this upper part, we are doing the deep cuts by using a pocket function again. We'll always cut a little bit to the right, a little bit to the left, to make enough room for the end mill. Once this is done, we can use the ramp function. The ramp function makes sure that the vertical surfaces also get this nice treatment of making them very smooth and precise. And because of tool deflection, we will run the ramp function twice. Now it's time to mount the 90-degree chamfer tool. We go to our 0 point, but now we need to do something special. We don't have a reference like before on the subplate, so I move to a known surface, which is this one here, and with this command here, G92 Z-86, I can set it to Z-86. And now I can go to 0, 0, 0 and will move upwards to the desired position. I load up setup 4_B and will start the removal of the edges here. We are reaching the final step in the production cycle. I want to point out one decision, which is not cutting all the way through, not only for the holes but also for the cutting out phase. This will lead the parts to still be linked to the raw material, but only by a thin layer of 0.3 millimeters. And again, I'm just using tools to break this link here. I will go around the silhouette till I can lift the plate from the part I just produced. So right now we still have the excessive material here, which we can remove by using some pliers. Just grab it close to the edge and give it a little twist. It will most of the time easily snap off. After we have cleaned it so far, we can use other tools like these ones here to ensure that the edges are clean and good enough for our use in our machine. Thank you so much for watching. I hope you enjoyed it. This is the result we achieved today, and I hope I see you in the next one. See you. Bye.